Understanding lens, concave and convex lens, ray diagrams, and sign conventions. Physics for class 8, 9, and 10. Understanding lens, ray diagrams, and sign conventions. Draw a straight horizontal line. Mark 5 points at equal intervals along the line. Mark the point O at the center. O is the optical center. Mark the points F and C on both sides of O. F is a focus and C or 2F is a center of curvature. Draw a vertical line representing the lens. For rough sketches, a line will suffice, but in some cases you may have to draw a full concave or convex lens. Draw an upright arrow object to the left of the lens. Object is always to the left of the lens. Its position will be as per the question. Here the object is between C and F. For convex lens, from the head of the arrow, draw a horizontal line up to the lens and then extend it through the focus F. From the head of the arrow, draw another line to O, optical center, and then extend it. The two lines will meet at a point. Intersection of the two light rays is the image of the head of the object. Image is inverted here. Now, some of the tips. Do not write object or image inside the arrow. Do not make the arrow so thick. Here we have done it for ease of understanding. Mark the object AB and the image A-B'. You may draw the full lens, but for sketch, rough sketch, and numerical work, calculations, a line is enough. Mark arrowheads in all lines representing light rays. A line without an arrow is not a light ray. Note the characteristics of the image: real, inverted, enlarged. Now, if the lens is concave, if we have a concave lens, how shall we proceed? Let us see. The first steps would be the same. Draw a straight line. Mark 5 points at equal distance. The middle point would be O and F and C on either side. Now, from the head of the arrow, draw a horizontal line up to the lens. From F on the left of the lens, draw a dotted line up to that point and then extend it as a solid arrow further. The dotted line represents the light ray produced backwards. From the head of the object, draw another line passing through O. The point of intersection is the head of the image. Note the characteristic of the image: virtual, erect, diminished. Now, understanding the sign conventions. Consider the principal axis as the x-axis and the vertical line through the optical center as the y-axis, and the optical center itself as the origin. So we have an x-axis, we have an y-axis, and we have the origin O. So it's just a graph: x-axis, y-axis, origin. The object is to the left, so object distance is negative. Object distance is always negative. The image is to the right, so image distance is positive in this case. The object height is above, so it is positive. The image height is below, so it is negative in this case. Now, sign convention for convex lens and concave lens. Look at the diagrams. Convex lens, the parallel rays meet at F on the right side of lens, so F is positive. In concave lens, the parallel lines diverge and when produced backward, meet at F, which is to the left of the lens. So in concave, it is minus. So F is positive for convex lens, F is negative for concave lens. So let's recapitulate. For convex lens, object distance is negative. Object distance is always negative because object is to the left of the lens. Image distance is positive if it is to the right of the lens, as in this case. Focal length is positive, it is to the right of the lens. Object height is positive, it is above the horizontal. Image height is negative, it is below the horizontal in case of inverted image. Now, concave lens. Object distance is always negative. Image distance is negative. Focal length is negative. They all lie on the left of the lens. Object height is positive, above the horizontal. Image distance is also positive since the image is erect. When things are explained logically and stepwise, it is so easy. Goodbye.